Hey there. So today we are going to be finding this general antiderivative for this thing right here, this monster, and this is the second way of doing the integral from 0 to pi of this. But today we are also going to be finding the generic antiderivative, and this method was devised by my friend Sankalp Sundar, so thanks to him for coming up with this, and frankly this is my favorite method, but the most elegant method is going to be up next. So let's get started. So we are going to find a generic antiderivative first, and then if we want to find the integral from 0 to pi, we just have to plug in the bounds. So his method is that we can do a substitution here. So if you notice this entire thing, if we call it f of x, then this right here is also f of x, because there's an infinite number of signs over here, but there's infinity minus 1 signs inside, which is still infinity. So we have the identity that f of x is equal to the sine of x plus f of x. So now let's just keep that aside for a while, and let's do some u sub. So let u equal x plus f of x. That's the argument inside the sign right here. So if u is equal to x plus f of x, well, what is f of x? F of x from this identity is just the sine of x plus f of x. And well, what is x plus f of x? We just defined u to be x plus f of x, so this is nothing but u. So we have u equals x plus sine u. So we solve for x and we get that x is nothing but u minus sine u, and if we differentiate both sides with respect to u, we'll get that dx is equal to 1 minus cos u du. And now we are ready to find the generic antiderivative. So what is the integrand? Well, the integrand is just sine of u, because we have sine of x plus f of x, which is just sine u. So sine u, and then dx becomes this right here. So sine u times 1 minus cos u du. So now let's multiply by -1 the inside and outside of the integral. And what is minus sine u? Well, minus sine u is nothing but d cos u by du. So in fact the du's cancel out, and we are just left with integrating cos u minus 1 with respect to cos u. Right, because if you distribute this minus sign inside, then you'll just get 1 minus cos u becomes cos u minus 1, and you can do another substitution with, let's say, w equaling cos u if you want, but let's just skip that part and just directly jump to integrating it. So if we look at just cos u as a variable, so maybe I should write it as w, then we are just integrating w minus 1 with respect to w, so that is nothing but w square by 2 minus w plus c. And well, what is w? That's cos of u. What is u? U is x plus f of x, so w is nothing but cos of x plus f of x. So we get that in the end I of x equals cos of x plus f of x by 2 times cos of x plus f of x minus 2 plus c. And if you want, you can find the integral from 0 to pi, which was the original question in the first video. So the integral from 0 to pi is of f of x dx is nothing but you plug in pi over here. So what is pi plus f of pi? Well, if you have watched the previous video, and if you haven't, you should. So if you have watched the previous video, you may remember that f of pi is nothing but 0. So this is in fact pi. So f of pi is x plus f of x evaluated at x equal to pi is just pi. So cos of pi is minus 1, and here also you'll have pi, so you'll have minus 1 by 2 times, and this is once again minus 1, so minus 3. And the next one is evaluating it at 0. So what is 0 plus f of 0? Well, if you remember from the previous video, f of 0 is 0. So cos of 0 plus 0 is 1. So we'll have minus 1 by 2 times, and well, once again you have 0 in the argument of the cos, so you have 1 minus 2, well, that's minus 1. So the minus minus cancel out, the minus minus cancel out, you get 3 by 2 plus 1 by 2, which is 2, and that's the answer. Thanks for watching.